Applications of differentiation to solve maximum and minimum problems. What we need to understand is that the derived function equals 0 at the maximum or minimum. In this question, we're told a closed rectangular box is made of thin metal. The length of the box is 3 times its width. The volume of the box is 36 centimeters cubed, and its width is x centimeters. And there's two questions being asked. Firstly, we're to show the surface area is given by 6x squared plus 96 over x in centimeters squared. And we're asked to find the dimensions of the box, which has the least surface area. Well, let's make a sketch of this rectangular box. So let's draw a cuboid. We know its width is x, and its length is 3 times its width. So we call one dimension x and the other one will be 3x. Since we don't know the other dimension, we'll call it h for height. The volume of the box is 36 centimeters cubed, which is length by breadth by height. So when we multiply the 3 dimensions, we see that 3x squared h equals 36. Dividing both sides by 3x squared, we see that h turns out to be 12 over x squared. So now that we have the dimensions all in terms of x, we should be at the surface area in terms of x. The surface area, there are 6 surfaces, but they repeat. So there's 3 different types. So if we multiply the length by the breadth, the length by the height, which is now 12 over x squared, and the breadth by the height, we see we have an expression for the surface area. And if we neaten this up, we should be able to make it look like the expression that we want. So multiply out each term. In this thing we're adding 12 over x and 36 over x is 48 over x. And now we're multiplying by 2. And we can see that our expression is the same as the one we've been asked to show. In the second part of the question, we want to find the dimension of the box with the least surface area. In other words, that will be when the derivative of the function for surface area equals 0. So we want to derive this function, the 6x squared plus 96 over x. Now 96 over x means 96 to the power of x minus 1. We multiply by the power and reduce the power by 1. So this becomes 12x multiplying by negative 1 times 96 and reduce the power by 1 is x to the negative 2. So we let this equal to 0 at the minimum. So we want to solve this equation. We might multiply each term by x squared, giving 12x cubed minus 96 equals 0. Then dividing across by 12 and adding 8 to both sides, we see x cubed is equal to 8. So x is equal to the cubed root of 8, which is 2. Or in the context of the question, 2 centimeters is more correct. We want to find the other dimensions as well. So we have the width. The length is 3 times x, and 3 2s are 6. So 6 centimeters is the length. And the height is 12 divided by x squared. So that's 12 divided by 2 squared, which is 4. And 4 into 12 goes 3 times. So h is equal to 3 centimeters.